good evening. Let us start. I will revise what we were discussing yesterday. Then we'll go to the next topics. We were discussing differences between scalars and vectors, which quantities are called vector quantities, which have both magnitude and direction, and also obey vector laws. Those quantities are called vector quantities. Okay. We can represent vectors in two ways. If you are representing them with some letter, then you put an arrow mark over that letter to indicate that it is a vector. And we can also represent vectors with arrows. Length of the arrow indicates magnitude. Tip of the arrow gives the direction. And types of vectors: equal vectors, opposite vectors, unequal vectors, collinear vectors, and
Sir,
coplanar vectors. Next is the other more important types of vectors are,
sir,
yes.
sir, I have a doubt in yesterday's one, sir.
Hmm.
Sir, what is the difference between opposite vectors and unequal vectors?
Opposite vectors are also unequal vectors.
Okay, sir.
Right. Next, another 2-3 important types of vectors. Position vector. Position vector. Okay. What is this? The name itself conveys the meaning of this vector. Position, a vector which is used to represent position of a point or position of a body. So it is a vector used to represent the position. Position means location, exact location of a point or body in space. Space means not outer space. Space means the region around us. We call it as a position vector. Okay. How will this be? Simple. To represent, if I want to tell you that the location of something or position of something, we need a reference frame. Like if you search in Google Maps location of some town or some point, some place, it will show you the latitude and longitude. Corresponding latitude and longitude, the intersection of those things, it will give you the position. It's like 36 degrees or some 40 degrees north, like that. Similarly, to represent the position of any point or any body, we choose the XY coordinate system, which we call as Cartesian coordinate system. Cartesian coordinate system. This is nothing new. It is a set of XYZ axis. Forget about Z axis. We'll let us talk first in 2 dimensions only, X and Y dimension. X dimension horizontal, Y dimension vertical. You call this as a Cartesian coordinate system. In this Cartesian coordinate system, suppose this is one point P. If I want to tell you the location of this point P, then I can do that in 2-3 different ways. One way is by giving you the coordinates of this point. Like, let us say its X coordinate is some 4 units or 4 meter, and its Y coordinate is some 5 meter. So if I tell you 4, 5, This is the location of that point in one way. This
Sir, X and Y are perpendicular to each other, sir.
yes. So this 4 and 5 tell you that you should go 4 meters along X direction. Then from there, 4 meter along X direction. From there, you should go 5 meter along Y direction. Then you will reach this point. It's just like giving directions. If someone asks you for some address, you will say that go straight, then take first left, like that. Similarly, if I want to convey the position of this point P, then I am taking the origin as a reference, and with respect to that origin, I will tell that this coordinates tell you that go 4 meters along X direction first, then go 5 meters along Y direction. Then you will reach point P. This is one method of giving the position. Using vectors, we can convey the position of the same point P using a vector, which we call as position vector. Position vector. How will be that position vector? If I draw a vector right from the origin to that point P, this is the position vector. The magnitude of this vector will tell you how far away the point P is from origin. Magnitude means length of the vector. This will tell you how far away point is from origin, or in other words, you can take it as distance. Okay, and the angle made by this vector with horizontal, let us say it is some theta. This angle will give you the direction. Length of the arrow gives you the distance, and angle made by the vector with x-axis gives you the direction. Suppose I tell you that theta is 30 degree, or theta is some 45 degree or 60 degree, like that. You can exactly reach that point P. Okay, so we call this as position vector. So a vector which gives you or which represents the position of a point in space is a position vector. Let us say there is some other point Q which is here. This is point Q. Its position vector will be different. It will be this. Position vector of point Q will be this. Magnitude of that vector gives you distance. Angle made by that vector with x-axis gives you the direction. So it is a position vector. Next, a very important type of vector, unit vector. Unit vector, very
Sir, I
important
did
vector
not
to
un-
understand.
Sir, I did not understand the position vector, sir.
Which point did you not understand completely or some part of it?
Sir, I don't know the coordinate system of x and y, sir.
Do you know x-axis, y-axis?
No, sir.
Have you drawn any graph anytime?
Yes, sir.
In the graph, you take x-axis and y-axis, right?
Yes, sir.
X-axis along horizontal direction, y-axis
Yes,
along
sir.
vertical direction. That's all. The technical name of that x-y axis is Cartesian coordinate system.
Sir, and coordinates x, y, you wrote 4 meter, 5 meter.
Oh, you forget about that. You forget about that. You leave it and you can understand it directly
Sir,
from here.
actually, what is position vector, sir? I did not understand the total.
What do you understand from this sentence?
It represents the
I
position.
want to tell you the position of some point. How can I tell you that? I should give you, first of all, I should take some point as reference, right? Suppose I want to tell you my address. Let us say we both live in the same city. I want to guide you to my home from your home. First of all, I should give you the distance, like my home is 2 kilometers away, 5 kilometers away from your house. Then I should tell you that you should go towards east or northeast, or you first start straight from your home, then take right, then take left. You will reach my home, right? You need some information like this to come to my home from your home.
Yes, sir.
What two basic things you need? You need the first thing, distance from your house to my house. Then you need the direction in which you should travel. These two
Yes,
things
sir.
are conveyed by the position vector.
Sir, I have a doubt.
Uh,
Sir, by the position vector, here magnitude and the angle with the x-axis or y-axis, those only matter, sir. Direction doesn't matter.
Angle in itself is indirectly direction.
Okay, sir. Thank you, sir.
Here, we cannot convey all directions only by north, east, west, south.
Okay. Sir.
So position vector is a vector which is used to convey or which is used to represent the position of a point. That's all. Position of a point in space. Space means the space which is enclosed between this x and y axis. You will be coming across some new terminology as the subject advances, as you start learning higher and higher topics. You'll be coming across new terminology. You should be able to relate that new terminology with what you already know. Like this Cartesian coordinate system, it is just a new name, that's all. You already know it. The set of x and y axes in mathematical language or in scientific language, we call it as Cartesian coordinate. Cartesian, name of the scientist who proposed this system. Coordinate system, coordinates, location of points. Okay. Next, unit vector, a very, very important type of vector. What is this unit vector? To understand this, okay, let us say there is a junction, a crossroad. In every city, in every town, there will be such a crossroad. This path will be going to some destination, this path to some destination, this path to some, this path to some. Okay. Let us say this is a highway. This is a highway. If you go in this direction, let us say you go to Hyderabad. If you go in this direction, you go to Bangalore. Okay, and if you go in this direction, you go to say some Chennai. And if you go in this direction, you go to Mumbai. Okay. And if you had observed, the R&B department, they might have placed a signboard here at the junction, near the junction. That signboard, it will have information like this. This looks something like this. 1 minute. Just a minute. something like this. Okay, so on that signboard,
Sir, it is not visible, sir.
Sir, presentation is not.
yes, it will be, that signboard might look something like this, right? On this, the names of the cities and the distances will be written. So let us say it is written like this: Hyderabad, a small arrow like this, some 200 kilometer. Okay, then Bangalore, arrow like this, some 300 kilometer. Okay, Chennai, 500 kilometer, or Mumbai, arrow like this, 400 kilometer. Right, a signboard like this
Sir?
will be
Sir, and
placed.
in milestone also it will be there, sir.
Milestones give you only distances, they don't tell you about direction. So this signboard, which is at the junction, suppose on this signboard, if you don't find these arrow marks, it is just pasted like this, and you don't know, you are new to that region, and you don't know which road takes you to which city, which place. And you see a signboard like this: Hyderabad 200 kilometer, Bangalore 300, Chennai 500, Mumbai 400. Can you come to know which path will take you to which road? If you want to go to Hyderabad, let us say, which is 200 kilometer, you will be in confusion whether to go this way or this way or this way or this way. So this 200 kilometer is only the magnitude. It is only magnitude. Only magnitude is not sufficient to reach your destination. You need the direction also. Okay, and that direction is conveyed with the help of these arrows. Like if I put a small arrow like this, then this arrow tells me that I should go in this direction to reach Hyderabad. This arrow tells me I should go in this direction to reach Bangalore. I should go in this direction to reach okay, Chennai is downward, so I should go in this direction to go to Chennai, and in this direction I will go to Mumbai. Without these small arrows, the entire board is useless. Entire board is useless. Whatever distances or cities, whatever you write, other information, it is completely useless without these small arrows. That is their importance. Okay. And what is the purpose of this arrow? What information do they convey? They give you the direction in which you should start. These arrows tell you the direction in which you should start. Okay. And to tell you the direction in which you should start, a small arrow like this is sufficient. I need not draw a arrow right from this junction to Hyderabad, which is 200 kilometer long. You don't need an arrow which is 200 kilometer long to tell you that you should go in this way. A small arrow which is even 2 centimeter is enough, right? So what we are understanding from that arrow is the direction in which we should start. So I will call this arrow, I can call it as a vector. I will call this as a vector. So I will call this vector as a unit vector. Unit vector. The purpose of this unit vector is to convey the direction. That's all. And we define this unit vector like it is a vector whose magnitude is 1 and which points in some convenient direction. Which points in some convenient direction. Convenient direction means the direction which we want. or which is required by us. So first of all, note one thing, it is a vector, unit vector is a vector, and the moment I say vector, two things should come to your mind. One is it should have some magnitude. Second is it should have direction. Now what is the magnitude of this unit vector? It is 1. Magnitude is 1. That 1 can be 1 meter, that 1 can be 1 meter per second, that 1 can be 1 meter per second square, that 1 can be 1 Newton. It can be any quantity which you are representing, but unit 1. Okay. And what will be the direction of unit vector? It shows our convenient direction, or the direction which is required. This is one general example. The arrow marks which you see on the signboard of near the junction, they can also be treated as unit vectors. Okay. But if you take them technically in physics, how we use these unit vectors is, see, to describe the position of any body, we will be using XYZ axis, as I was telling you here, which you call technically as Cartesian coordinate system. We will be using XYZ axis. What are these XYZ axes? A horizontal line which represents the horizontal direction. You call it as X-axis. A vertical line which represents the vertical direction. This is called Y-axis. Y-axis. These two are perpendicular to each other. X-axis horizontal, Y-axis vertical. Both are perpendicular to each other. And another axis which is perpendicular to both these axes, like this. It is Z-axis. X horizontal, Y vertical, Z perpendicular to both X and Y. That means if you, with respect to your screen, X-axis is towards your right and left. Y-axis is up and down. Z-axis is out of the screen and into the screen. A line running out of the screen and into the screen is Z-axis. And the point where these three axes intersect, you call this as origin. Origin. Intersecting point of the three axes is origin. We take, with this complete thing, we call it as a Cartesian coordinate system. The position of any body or any direction can be represented using this XYZ axis. Okay. Now, any direction that I want to convey, whether it is east or west or south or northeast or southwest or vertically up or vertically down or diagonally, any direction that I want to convey can be represented using these three XYZ axes. Infinite directions can be represented using XYZ axis. Okay. If I ask you how many directions are there, some of you might tell there are 4 directions, northeast, west, south. Some of you might tell there are 8 directions, northeast, southwest, northwest,
Southeast, southwest.
Some of you might tell there are 2 more directions, vertically upward and vertically downward. But practically, there are infinite directions. If you look around you, you will find infinite directions.
Sir, can you scroll up?
This is east, this is west, this is north, this is south. East is one direction, north is one direction, west is one direction, south is one direction. Okay. Northeast is one direction, northwest is one direction, southwest is one direction, southeast is one direction. 8. I can have one more direction which is like this, 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 like this, like this. I can have infinite number of directions in 3 dimensions. So only northeast, west, south, or left, right, or up, down are not sufficient to represent these infinite directions. Then how can we represent all those directions? Using XYZ axis. If I give you values of X, Y, and Z, you can come across all these infinite directions. How we will come to that slowly, not now, not everything at once. Now let us come back to unit vectors. We are trying to understand what is a unit vector. It is a vector whose magnitude is 1 and which points in some convenient direction. The three basic standard definitions that we take are x direction, y direction, and z direction. Combining these three directions, you can represent infinite directions. These are like our digits from 0 to 9. There are only 10 digits. Combining these digits, you can write infinite numbers by arranging them in one proper order. You can write infinite numbers. There is no end to that. Similarly, using these three x, y, and z directions, we can represent infinite directions. Okay. Now, a vector, a unit vector which points along x direction, a unit vector which points along x direction, like this. Unit vector which points along x direction. And take another unit vector which is pointing along y direction. And take another vector which is pointing along z direction. Like this. These are the three unit vectors along x, y, and z directions. And we give special names to these unit vectors. We give special names to these unit vectors. What are the names that we give? A unit vector which is pointing towards x direction is represented by I cap, small I. We should not use capital I, small I. And a unit vector representing y direction is denoted by j cap. Unit vector along z direction is represented by k cap. Okay.
Sir,
P cap, j cap, k cap. This is cap, CAP cap. CAP cap. It is, we put this cap to show that it is a unit vector. Normally, if I write a vector quantity like P, to tell that it is a vector quantity, we put an arrow over its head. But these are special vectors, unit vectors. To tell that this is a unit vector, we put a cap over its head. Cap. Okay, and we read it the same way: I cap, j cap, k cap. What are these things? These I cap, j cap, and k cap are doing the same work as these arrows do on the signboard. Purpose of these arrows is just tell you the direction. Similarly, purpose of these unit vectors is to just tell you the direction. That's all. I cap tells you, if you see I cap, you should understand that you should go in this direction, x direction. If you see j cap, it tells you that you should go in j direction, y direction. If you see k cap, you should understand that you should go along z direction. Okay. Now, let us take some examples to understand how we use these unit vectors. Suppose I want to
Magnitude is always
convey.
one. Magnitude is always one, sir.
Magnitude
Okay.
of a unit vector is always 1. For example, I want to convey, I want to tell you that you start from origin and go 2 meters along x-axis. Instead of telling you this lengthy sentence or in a lengthy manner, I will simply tell you that (2 meter I cap). This tells you you should go 2 meters.
Sir,
From where? Origin. All things start from origin. You should go 2 meter. In which direction? In the direction of I cap. What is the direction of I cap? Along x-axis.
Sir,
Yes.
sir, can we write 2I cap also, sir?
But you should have some unit, no? 2 means what is this quantity? Is it 2 liter or 2 kg or 2 second or 2 Newton? It must have some unit, the
Okay.
physical quantity which you are representing. Okay. And if I want to tell you that you should go 3 meter in y direction, then I will tell you, I'll write it like 3 meter j cap. By reading this 3 meter j cap, you should understand that this number 3 is the magnitude of what quantity? Meter is unit of length. So 3 meter is the length or distance. 3 meter is the distance. But in which direction? In j direction. Direction of j cap. J cap. What is the direction of j cap? Along positive y axis. If I tell you 4 meter along z axis, I will write it like 4 meter k cap. So 4 meter tells you the distance, magnitude. K cap gives you the direction, z axis. Okay. Now,
Sir,
another
we
small thing.
take as sir, we take
If
unit as meter only, right?
I am representing displacement here, it can be force, it can be velocity, it can be acceleration, anything.
Okay.
To easily understand, I am taking the example of displacement here. Suppose I tell you, I write like this, minus 2 meter I cap. What does this mean?
Sir, negative
Sir, to the
x-axis,
left.
sir.
Negative x-axis. From origin, if you go right, it is positive x-axis. From origin, if you go left, it is negative x-axis. From origin, if you go up, it is positive y-axis. If you go down, it is negative y-axis. From origin, if you come out of the screen, it is positive z-axis. From origin, if you go into the plane of the screen, it is negative z-axis.
Sir, but distance is never negative. No?
Displacement can be negative. We are talking about displacement here. Distance is a scalar quantity. Displacement is a vector quantity.
Okay, sir.
So if I write minus 2I or minus 2 meter I, the information that is carried in this representation is you should
2
go
meter
2
along
meter
negative
distance.
x-axis.
You should go 2 meter, but in which direction? Minus I. Minus I indicates this direction. Starting from origin, you should go left. If I write minus 3 meter j cap, you should go down 3 meter. If I write minus 4 meter k cap, you should go into the screen, into the plane of the screen, 4 meter. So try to understand the work that these IJK are doing here. They are simply pointing towards a particular direction. They are pointing towards a particular direction, that's all. They are telling you that you start in this direction. And how much should you go? That is given by the magnitude. How far should you go? That is conveyed by the magnitude. Okay. Now, see this. If I write something like this, what do you understand from this? After this basic idea, I will write a vector like this. Suppose vector A is equal to 2I cap plus 2j cap. What do you understand from this?
Sir, it means two along the x-axis and two along the y-axis.
Yes. See, okay, meter is common here. 2 meter, 2 meter. Right. So first thing from this thing you should understand that you should go 2 meter starting from everything starts from origin. You should go 2 meter.
Right side.
In which direction? In direction of I cap. I cap is positive x-axis. So you start from here, go 2 meter up to here. Okay, or I will take another this. This is positive x-axis, negative x-axis, positive y-axis, negative y-axis. Okay, so you should start from origin and go 2 meter along I cap direction. I cap direction is positive x direction, like this. Let us say you come here 2 meter. Then what does this convey? Plus 2 meter j, plus 2 meter along j direction. From here, not from origin again. From here, you should go 2 meter along y direction, j cap direction, which is this. And this end up here. You end up here. You started from origin and you ended up at point A. Right. Now, if I draw a straight line from O to A and put an arrow like this is your position vector. This is your position vector. So this position vector is written like this: 2i plus 2j. 2i plus 2j. If I write another vector, say vector b as 2i minus 2j. 2i minus 2j. This 2i tells you that start from origin, go 2 meter along x direction, like this. You come
Down,
here.
sir.
Minus 2j tells you go 2 meter along minus j direction, minus j, which is negative y-axis. You end up here. Now, if I connect origin to this line, this is vector OB, vector OB. So this is another position vector which gives you the position of point B. Right? If I write another vector C as minus 2i plus 2j.
Sir, you are not writing cap.
Okay. This cap, if you write it, okay, well and good. If you go as per the rules, you should put the cap every time. But even if you don't write the cap and you see I, J, K, they imply that they are unit vectors. Writing cap is advisable, suggestible. Technically, it is correct way to represent a unit vector. But even if you don't see a cap and you see IJKs, you should understand that they are unit vectors. IJKs are exclusively used to represent unit vectors. Okay, minus 2i plus 2j. Minus 2i plus 2j. How will be this vector? Minus 2i from origin, negative
To minus
x-axis.
That's a
x.
minus x-axis.
Then
And 2
positive
above,
y-axis.
sir. Positive.
Here.
Plus
You
y.
end up here. This is point C. Now, if I draw a line from O to C, this gives me position of point C, position vector of points. If I write vector D as minus 2i minus 2j cap, where does this go? We start from
Sir,
origin.
minus 2i means 2 minus
Like
x and minus j means minus y.
this is the position vector of point D.
Sir,
Like this.
the measuring unit after minus 2.
Okay, it's meter. It's meter.
Sir, I have a doubt.
Oh.
Sir, while representing, we can't we take 2 common?
No. Okay, you can take 2 common. You can write it as 2 into I plus j. Okay, you can take it.
minus I, sir.
Sir, it also conveys same meaning, sir.
It conveys the same meaning, but writing like this gives you more clarity. 2I plus 2j, 2I minus 2j,
Sir, I have a
or
doubt.
3I minus 5j. These things give more clarity.
Sir, one I or one J, can we write as I or I and J, sir?
I, that's all.
Okay.
These are unit vectors. Very, very important things. If you have clarity on unit vectors, the coming topics will be easy for you.
Yes, sir. Completed.
I have told you only in 2 dimensions. We have the unit vector also, which is in z direction. Suppose if I write a vector like this, tell me what do you understand from it? A vector some A, I'll write a vector A as 2I plus 3j plus 4k. Caps are there.
Yes, sir.
What does this vector tell you? What information does this vector A convey?
Sir, 2 units from x-axis. After upward 3 units, sir.
J,
From J.
J 3 meters, sir.
Not from J. Not from J.
To Y, sir. To Y.
A reference point. J is a direction. Along J.
From Z axis 4 meters.
Yes, sir. Along J.
This vector
And
A,
Z axis
A vector
4
equal to
meters.
2A plus 3J plus 4K tells you that you start from origin, go 2 units along I direction like this, go 3 units along Y direction like this, then go 4 units along Z direction, which will be out of the plane of the screen, which I cannot show here. We should visualize it. Okay. Now, what you do is you practice these different vectors by taking any one corner of your room as the origin. Take any one corner of your room as the origin. Your room will be like this, no?
Yes, sir.
So take this corner. This will be your x-axis. This will be your y-axis. This will be your z-axis. Okay. And this will be negative x-axis. This will be negative y-axis. This will be negative z-axis. These negative x, y, z axis might go into the adjacent rooms also. In this room, try to represent this vector. Suppose you want to convey the position of the ceiling fan. By taking one corner as origin, you want to convey the position of ceiling fan. Then how much distance should you go along the x-axis? How much distance along y-axis? How much distance along z-axis? So that you reach the ceiling fan. That is a position vector of that ceiling fan. Or you take some photo frame which is hanging on the wall. By taking this corner as the origin reference, what will be the vector of this position vector of this photo frame? Like we should go some 2 meter along x direction, then 1 meter along y direction. Then this position vector can be written as 2I plus j. So like this, try to think of some vectors using position vectors I, j, k. This is the work for you from this topic. Okay, so that's about unit vector.
Sir, you said the next one is null vector.
Null vector. Next one. Okay, we'll finish this also. It's simple thing. Null vector. The last type of vector is null vector. NULL. Null means void, which is nothing. Zero. Null. So
Zero.
null vector is a vector. It is a vector whose magnitude is 0 and its direction is indeterminate. Indeterminate means which cannot be determined. So a vector whose magnitude is 0 and whose direction is not known, you call it as a null vector. This null vector is like 0 in vectors. It plays the same role as what 0 plays in our digits. The same role is played by null vector in vectors. If I add 2 plus 2 and minus 2, I'll get 0 in ordinary algebra. Similarly, if I add a vector which is in this direction, 2 meter, and another vector which is 2 meter but in opposite direction, then I will get the result of these two things. The result of these two things will be a null vector. 0 here, null vector here. Okay, these are the types of vectors. Try to focus more and understand clearly the unit vectors. IJK, very, very important. If you have doubts, you just again refer to the recorded lecture, get clarity, and understand what you mean 2a plus 2j plus 3k or 3a plus 2j minus 4k. In how many different ways we can write all these things. You just try to get clarity on this. Very important.
Let's scroll down.
Sir,
Yes.
sir, that means we cannot determine the
Sir?
direction of the vector.
Yes.
Okay, sir. But But so it is like similar to null point, right?
Null point. Yeah.
Sir means the point is at origin only. It doesn't change.
No. It's not like that. Not origin. You'll get more things when you study. When you come to know about addition and subtraction of vectors, then you will understand more clearly what is vector. What is this null vector?
Sir, how can it be not indeterminable?
That's what I'm telling. When you understand addition and subtraction of vectors, and when you take some examples of practical vectors like velocity, acceleration, you will get more clarity on that.
Okay.
You should know things like displacement, velocity, acceleration to understand clearly what is a null vector. Okay, so that's it. We'll continue in the next class.